Today we're going to compare data sets. We're going to start off by comparing their spread and their center. So the first example on the left, it says, based on the two data sets represented below, complete the following sentences. The first one says the center of set P is greater or less than the center of Q. So let's look and see. Labeling here, the center on P is kind of at that peak there, where on set Q, it's a little bit more spread out among these values here. So which one would you say has a greater center? Set P has a greater center than set Q. Next, we're going to look at the spread. How far is the data spread out? So on set P, I can see that it is spread out this way. Where on set Q, it goes from that 39 all the way to 58. So which one has more values and is spread out more, would have a greater range value, would be set Q. So we want to say the spread of set P is less than the spread of set Q. We can do the same thing with dot plots. So we have set N and O. The statements say the center of set N greater or less. So I see my peak here. The center is about there, where in set O, the center is about here. So to complete our sentence, the center of data set N is less. See how it's kind of towards the left? It's centering around 10. Than the center of set O, which is more around 15, 16. The spread of set N. Labeling my two graphs here just as a visual. Notice the O goes all the way to that 23. The spread of set N, I would say, is definitely less than the spread of set O. Next, we're going to talk about the shapes of data sets. So dot plots and histograms can be used to identify the shapes of our data distribution. So here are three different ways we could see our data distributed. Skewed left, or I like to call it squished on the left. If I was to push down on this left side, all my data would kind of move over to the right side. So squished or skewed left. People also talk about the tail, where the tail is. So you might read a question that says the tail of the data is on the left side. That would tell you that it is skewed left. Symmetric is exactly like it sounds. It's very evenly distributed and balanced in the data distribution. Skewed right is also like left. I like to think of it as squished. Where is it squished? On the right side. So the majority of the data is on the left. The tail of the data would also be on the right. Filling in our blanks here, in a symmetric data display, the data points are evenly spread on either side of the center, and then our mean would be equal or close to equal, approximately equal to the median. In a skewed data display, the data points are unevenly spread on either side of the center, the median, and therefore the mean and median are not equal. In our examples, we're going to state whether each data display below is either skewed left, symmetric, or skewed right. So the first one is an example of symmetrically distributed. It is a symmetric data display. You can see how it is balanced and evenly distributed there on the left and the right. The next one, this dot plot, if I was to squish on this right side, the majority of the data is pushed over to that left side, so this is skewed right. In the next one, we've got a dip or a squish on the left side, so this is going to be skewed left. The next row, squished here on the left, so skewed left. The number of fish dot plot here looks very symmetric. And the last one, we've got a tail or a squish here on the right side, so skewed right. So that's our lesson on comparing and the shapes of data sets. That completes our data display section of our notes. We're going to move on next to scatter plots. Let me know, guys, if you have any questions, and I'll see you in class.